gonna continue with our lesson today, which is Pythagoras theorem. Today, what we're gonna do on the conclusion, we're gonna be talking about this. The first thing is the strategies that I've used to achieve my objectives, and the resources that I've used. And as you've seen, I've used some videos from YouTube, and I've used some worksheet from the CAPS document and study guide grade 8. That's where I took all the material and the information. Okay, on my conclusion, I want to emphasize the important points on when you're dealing with the measurement using the Pythagoras theorem. Okay, now I'm just gonna play a video. Okay, I'll just first have to explain what is happening. The first thing that the students must be aware of, the first thing, the Pythagoras theorem is being used on the right angle triangles only. It cannot be used to other. It's proof the right. You can use it to other triangles, but it must be used when you want to find the hypotenuse. It must be used on the right angle triangle. Okay, you have to know that the hypotenuse. The first thing you have to know, the hypotenuse is opposite to the right angle triangle, which is equal to 90 degrees. And the second thing that you have to know is that the formula. When you go to the formula, is that the hypotenuse is equal to the sum of the square root of the two sides, which are legs of the right angle triangle. That's what we have to know. And the third thing is that you can also be given all the sides of the right angle triangle or the triangle itself, and they'll say prove it's whether it's a right angle triangle or not. So you remember, you'll go back to the formula, and you go back to the formula and substitute all the values, and then that's where you will see if the square root of the two sides are equal to the longest side. Then you will say, you can conclude whether it's a right angle triangle or not right angle triangle. So now I'm just gonna play a video just to emphasize these two key points to students, that they mustn't forget that the important thing with the right angle, with the Pythagoras theorem. So I'm just gonna play it just shortly now. So that's okay. Our lesson here, we continue with the Pythagoras theorem. Is the topic. It's Pythagoras theorem. And another thing we remember, we also talked about the inverse. That's where we are given the inverse of the Pythagoras theorem. That's where you are given all the sides. Then they'll say prove it is a right angle triangle or not a right angle triangle. So now shortly I'm gonna play a video here just to emphasize this point. Okay, it starts here.
Here's another interesting one. What if you have a unit square that's cut in half along a diagonal? Each side of the square is 1 unit long, but how far is it from one corner of the square to the other along the diagonal? Well, since the diagonal divides the square into two right triangles, we can use the Pythagorean theorem to tell us that unknown distance. We label the legs of the right triangle A and B and the hypotenuse C. And since we know that A and B are both 1, we can plug those values into the Pythagorean theorem equation, which gives us 1 squared plus 1 squared equals C squared. Now we solve for C. 1 squared is just 1, so the left side of this equation simplifies to 1 plus 1, which is just 2. That means C squared equals 2, and if we take the square root of both sides, we get C equals the square root of 2. So that's how far it is across the diagonal of the unit square. Okay, so that's how you use the Pythagorean theorem to find the length of an unknown side of a right triangle, which is its most common use. But there's another way that you can use the Pythagorean theorem that I want to mention. You can also use the Pythagorean theorem to test a triangle to see if it truly is a right triangle. You know, in case you're not already sure. For example, what if someone shows you this triangle and asks, is this a right triangle? Well, it looks a lot like a right triangle, but it doesn't have a right angle symbol, and it would be kind of hard to tell if this angle is exactly 90 degrees just by looking at it. Maybe it's really close to 90, like 89.5 degrees. No worries, the Pythagorean theorem can tell us for sure if we know.
Okay, just to explain here, that's where we're talking about the converse of the Pythagoras theorem. So here he's explaining, as I've said, that you are given all the sides, three sides of the right angle triangle. Now we just have to prove it. That is it a right angle triangle. So now we're starting that. And another thing that he have just mentioned here, you can use the Pythagoras theorem whether you are given the hypotenuse. You can be given the hypotenuse and the one side, but the other side. Also, you can use the formula. But the other thing that the students have to remember is that you have to make the subject of the formula of the side that is required to be found. So it can be either one side of we have three sides on the right angle triangle, but if we are given the in those special cases, you may be given you should be given the angle, the hypotenuse, or maybe one side. But the other thing that is important, you have to get another side. So as I've said, but you will have to make some changes and make that side the subject of the formula. So we'll carry on and continue with the video. I just wanting to emphasize that.
Know the lengths of all three sides of the triangle. If we know those lengths, A, B, and C, then we can just plug them into the Pythagorean theorem equation to see if it holds true. In this particular case, since the two shorter sides are each 3 centimeters and the longest side is 4 centimeters, we can plug those values in for A, B, and C and simplify to see what we get. 3 squared is 9, so on this side of the equation, we get 9 plus 9, which is 18. And on the other side, we have 4 squared, which is 16. Uh-oh, that doesn't look right. Our equation simplified to 18 equals 16, which is definitely not a true statement. That means that the three sides of this triangle do not work in the Pythagorean theorem. They don't fit the relationship a squared plus b squared equals c squared. And
okay, as I've said, as you have proven that as the formula is the key. Also here is the formula, and the right angle triangle is the angle here is the key. So as I've said, that the formula is equal to c squared is equal to b squared plus a squared. You see, if written here, I've just gonna go back just a bit here. You see here, you have calculated here. You have calculated. Oh no, I can't find it correctly. Let me try. Okay, you see, this side is not equal to the Pythagoras to the hypotenuse. So this is totally indicating that we know this is not the right angle triangle. So we're gonna carry on.
A true statement. Don't fit the relationship a squared plus b squared equals c squared. And since the Pythagorean theorem tells us that all right triangles fit that relationship, this triangle must not be a right triangle. Alright, so now you know what the Pythagorean theorem is, and you know how to use it. You can use it to find a missing side of any right triangle. And you can also use it to test the triangle to see if it qualifies as a right triangle. But as you can see, it takes a lot of other math if it qualifies as a right triangle.
Okay, as I've explained here, you see you can test any side on the right angle triangle. As I've said, you will be given the angle, you'll be given the angle, and you can be given the angle, but one side you won't be given. Not always is the case that you will be given you will not be given the hypotenuse. You might not be given this side, which is the adjacent side. This one is an opposite side. Okay, another thing, you'll be tested that is it a right angle triangle. In these cases, that's where you are given all the sides of the right angle triangle. So yeah, so on my conclusion here, that's what I want to emphasize to the student, and we'll do some few examples here just to conclude and to see if my objectives were successful. So now I'm gonna just do two few examples here for the students, just to understand the concept and the Pythagoras theorem. Okay, now what we're gonna use, I'm gonna use here. Sorry, I don't have a proper board, but I'm gonna try to show it here. So now you are given on the worksheet, they said work out the missing side here. So now what we're gonna do, first we have to write the formula of Pythagoras theorem. Is equal to b squared plus b squared plus c squared. Okay, here I've made a mistake, but it's okay, it doesn't matter, because it's usually, most of the cases, the formula is written like this: c squared, it's always the subject of the formula, which is our This is our hypotenuse, the longest side. But we'll have to prove it if it's the longest side here. So what we're gonna do, okay, I'm gonna write as it's usually written like this on most of the problems or on the textbooks, plus a squared. So now we have to substitute the sides. Okay, what is missing here? It's the hypotenuse. So what you're gonna do here, because we said that the hypotenuse is always opposite to the right angle triangle. So the opposite side, that's what they are talking about here. So now, which means our substitute formula is correct here. B squared, we can decide which one is B, is 12 squared plus 5 squared. Okay, 12 squared is usually 144, but I'm just gonna do it here on the calculator just to make sure that I'm doing the correct thing. 12 squared is equal to 144, as I've said, is equal to 144 plus 25. Okay, another thing to prove it here is 25. 5 squared is equal to 25 either way. 5 squared is equal to 25. Okay, if we add this, the side is gonna be 144 plus 25 is equal to 169. It's equal to 169. So then we square root to remove this square root here, and then we also square root here. Now we want the C as a substitute of formula. What is the square root of 169? Is equal to 13. So here's our answer. And another thing, we shouldn't forget to write the units. 13 centimeters. Therefore, it concludes that this is our hypotenuse because it's the longest side. Here is 12, here is 5. So we found our hypotenuse. Okay, another problem that I've said here, we're gonna use our formula again here. So it's gonna be C squared. Now we have this opposite side now, which is missing. It's not the hypotenuse, because the hypotenuse, it tells us we already have the hypotenuse, we have the 10 meter, it's 10 meter, we have the adjacent side here. So now we first have to write our substitute of the formula first. You have to write it. You can't just substitute because that might confuse you. It's got to be squared. Okay. Now what we have to do, we have to substitute. We have 26 squared equal to, you can decide which side you call it B on both of this side. Okay, I'm just gonna decide this is our B. Our X, the missing side, X squared plus 10 is equal to 10 squared. Okay, another thing what you're gonna do now, we have to remember, okay, what is 26 squared? It's gonna be 26 squared is gonna be 676, isn't it? And then another thing, what you have to do, it's X squared. Okay, what is 10 squared? 10 squared is usually 100, but I'm just going to do it here. It's 100. Okay, now what we have to do, we have to make X squared, this side which is missing, which is a missing side. Okay, we're gonna translate 100 to the other side. So now we're gonna just say X squared is equal to 676. And then if you translate, we shouldn't forget that if you translate the other number to the other side, it should change the sign. So now it's positive, now it's going to be negative. It's going to be 100. And I want to emphasize here, that's where some other students, they make a mistake here. If you translate, the sign changes. That's the rule. They mustn't forget that. Okay, so now we're going to we're just going to change just to make it look familiar, because now we're gonna say 676. Okay, let's place it like this just to translate it so that it's gonna be easy, as I'm teaching grade 8, so everything should be written so that they'll understand what is happening. So it's X squared. Okay, we minus 676 minus 100 is gonna be 576. So now we want this side, so we have to remove the square root. So we remove the square root, then we square root on this side. What is the square root of 576? 576 is 24, if I'm not mistaken. You see, it's 24. So it's 24, as I've said. Okay, that's our final answer. It's written in meters. So now what we found here is that this side is equal to 124 meters. So there's another problem we have just stated. Okay. Oh, sorry, another mistake that I've made here is just that I've written B, but here it's A. But I thought I'm thankful that some of my students have seen that. Okay, now we're going to do the problems where you are given all the sides, just that you have to prove and say the reason whether it's a right angle triangle or not. So here we are given the sides. So they said the converse of the theorem of Pythagoras, state whether the following it is a right angle triangle or not. So now what we're gonna do, we're gonna write the formula again. C squared is equal to B squared plus A squared. So as we are given all the sides, the longest side it's 17 squared. You mustn't forget to put the square root because everything is gonna be wrong. Okay, it's gonna be 8 squared plus 15 squared. Okay, now we have to prove that is it a right angle triangle or not. So what is the square root of 17 is equal to 289. Now it's square root of 8 squared is equal to 64 plus 15 squared, that's 15 squared is equal to 225. 225 plus 64. Already I've seen my answer. It's 289 is equal to 26 plus 64 plus 225 is equal to 289. Therefore, it is a right angle triangle, because we said that this the sum of the two sides squared, both of them squared, it's equal to the sum of the hypotenuse, which is also squared. So we've proven that these sides are equal to this side. So this is a right angle triangle, which means our angle is here, where it is opposite to the hypotenuse. Okay, we're gonna do another problem, last problem here. Okay, already here we also given the sides. Okay, we put our formula. It's B squared plus A squared. Okay, we substitute here, we check the longest side, it's 18 squared plus we put 11 squared plus 7 squared. Okay, now we have to find the square root of this, all of it. It's gonna be 18 squared is equal to 324 plus 11 squared is equal to 121. Okay, I'm not familiar with these numbers. Okay, plus 7 squared is equal to 49. So 324 is equal to 121 plus 49. 129, it's gonna be 170. It's 170. It's 170 just to prove it to calculator, because the student have to be sure that what I've explained throughout this lesson is equal to 170. So the reasoning here, therefore, this tells us, because we said the sum of the two sides, the squared two sides must be equal to the hypotenuse. Therefore, this is our hypotenuse. Therefore, this is not the right angle. Therefore, it is not the right angle triangle, is because the sum is not equal. And another thing what we can use here, if you are given problems like this, the students in grade 8, they always have to have the instrument, which is the protector, which is important, because if you measure here, it tells you, you see, it is exactly 90 degrees. You see the angle, because it's all you already counted, it's exactly 90 degrees. Now this angle you said it's opposite. If we double check here, you see it is not all, is not equal to 90 degrees. You see, maybe it's like 89, 89.5 or 88. So you see the angle is somewhere here. So I think that's what I wanted to emphasize with my students. That's why I've done some problems just for them to understand the lesson. I hope they have understood it. Thank you.